So I'll just give you a brief background about what is asset performance management and why the asset performance management has been so critical and widely accepted phenomena in the electrical assets or energy segment. What are the benefits and objectives of APM? What's the current state and future state of asset performance management? This we will be sharing our experience talking to different utilities and industrial customers globally. So we have seen different utilities and industrial customers at different stages of asset performance management. So I am generalizing this by putting most of the customers into the current state and some of the customer who have started getting into the future state of the performance management. We'll also talk about APM process and role of analytics, role of condition-based maintenance practices or condition-based maintenance systems, where mainly we will be focusing on what are the analytics that are used for planning and strategy purposes, and what are the analytics that can be used for daily operational management, like improving the performance, using the analytics for dynamic rating of electrical assets, using the analytics for day-to-day operations of the maintenance engineers or maintenance manager. Then towards the end of my webinar, I will focus on what should be the APM system look like, and also what's the role of IoT-based sensors in an overall implementation of APM system. So what is asset performance management? So if I talk about the objective of asset performance management is improving the bottom line of the P&L of the electrical utility or industrial customers, while no compromising on reliability of the electrical assets or electrical grid. So that's the crux of the asset performance management. How it is different from asset life cycle management? Asset life cycle management focuses on the complete end-to-end life cycle of the asset, right from planning stage to commissioning stage, then operational stage, and then finally decommissioning of the electrical asset. And it's mainly focused on inventory management and different kind of maintenance and repair activities that has been done on the electrical asset. And all of our customers, they are generally using enterprise resource planning software or system for asset lifecycle management. And sometimes they call it electrical asset management system. Okay. While asset performance management is entirely focused on how the electrical asset performance can be increased or optimized during the utilization or during the operation of the electrical asset. And such kind of processes or such kind of objective is not being covered by the ERP system or electrical asset management system. That's why there is a need of APM system. And why APM system is more relevant today. Today, if you see, everyone is looking into every country into going green, either changing the supply side situations, like investing more on wind farms, investing more on solar energy, but it is increasing the supply fluctuation in our electrical grid. Our electrical grid has been made or built considering the fluctuations in demand and supply, considering the minimum fluctuations in demand and supply. And also these demand and supply fluctuations has been mostly predicted, like early in the morning we'll have higher demand, during the day and during the night we will have stable or lower demand. So all the electrical assets has been conditioned or has been manufactured considering those situations. But when it comes to the renewable power supply, the supply fluctuations are higher. When it comes to the electrical vehicle energy storage system, and again, the demand fluctuations are higher. Gone are the days when people were thinking about night is the less power consumption time of the day. Today, nights, or in future, nights will become more power consuming when people will be charging their cars at the home in the night. So this increases the stress on the electrical assets. And then this is further being worsened with the climate changes. Everywhere we are seeing the climate changes. In UK, in UK, I'm seeing the climate has completely changed. I'm still seeing 14, 15 degrees Celsius today, while usually 5 to 10 years before, the temperature used to be like 6, 7 degrees. So this all has detrimental impact on the existing electrical infrastructure. That's why there is a need for more asset performance management during the operation of these electrical assets. And then there is a need for data-driven APM approach that provides sufficient power and sufficient decision support system to utilities and industrial customers for the new changes that we are seeing coming to our life. So the objective or the benefit of a typical APM system is reducing the unplanned downtime, basically reducing the unplanned outage of the electrical assets, lower the maintenance cost, increase the operational efficiency of the electrical asset. So whenever there are higher demand and supply fluctuations, we need to have control, or we need to have information to control the electrical asset in terms of loading, whether it is overloading or underloading. Then extend the asset lifespan. We are seeing a lot of surge in the demand of transformers. Every transformer manufacturer today has a lead time of 2 to 3 years. So at this critical time, everyone is looking for, how can I extend my asset life, my transformer life, for another 2 to 3 years? So that's the objective of asset performance management system. Lower the environmental health and safety risk. This is again, regulatory compliance, real-time alarms. How can I evacuate people who are working at the substation before any failure occurs? So I need a smart SMS email-based system that gives me sufficient notice period so that I can evacuate my substation or my working site before any failure occurs. So that's the kind of system utilities and industrial customers are looking for. And that helps them to manage everything remotely and digitalizing their current processes. So today, if an engineer goes to the site for offline and periodic testing or visual inspection, so the person, he or she, they enter the data into the they enter the data into the visual inspection report, or they perform the offline and periodic testing. But the analysis of this testing and visual inspection is done retrospectively after a week, or sometimes after 1 to 2 months. By that time, the asset has been either running into a risky state, or asset has been underutilized. So if the analysis has been instantaneous, then utilities and industrial customer will have more time, or will have more time to operate the electrical asset in a better way. So if we talk about current implementation, and again, as I mentioned you before, this is not a generalized this is not a generalized implementation. We have selected most of our customers whom we have interacted with, what is their current implementation of asset performance management processes, and what is the future they are looking for. So if I talk about the current implementation, it's mostly manual, complex, and error prone, where people are looking into the data from different systems. Like there are islands of automation for monitoring system. Transformer has 3 or 4 different kind of monitoring systems. Switchgear has a different monitoring system, cable has different monitoring system, and all this monitoring system data is being collected by different people, and then it is being analyzed by different people. They give their own own suggestions, and finally one team sitting at the headquarters is analyzing all this data and coming up with the planning. The same thing is happening, as I mentioned before, delayed analysis from offline and periodic testing results and visual inspection reports. Data duplicity. So there are data that is being that is being duplicated into control systems, maintenance management system, electrical asset management system, enterprise resource planning systems, workforce management system, legacy database. All of these systems has redundant data. Most of these systems are having the data that is completely redundant to each other, and then the data is not being utilized properly. The proper information is not coming out of this data. Next problem is, since we have these multiple databases sitting into the utilities or end users, so again, the maintenance of monitoring system, maintenance of these servers, softwares is becoming a problem for asset managers. Some of these systems are still owned by asset managers, but not the information technology IT team in the utilities. So most of their time today is getting spent on maintaining the monitoring system and maintaining these servers, PC softwares, rather than utilizing the data from these systems and improving their day-to-day activities and improving their planning process. There is a limited awareness of OEM agnostic monitoring system. There is a lack of comprehensive monitoring strategy where all the data should be collected into one system, and that data should be utilized for meeting the asset performance objectives. So how the future state should look like? It should be an automated, fast, insightful decision-making process enabled by APM systems. So all the offline or periodic testing, visual inspections must be automated so that real-time analysis and alarm notification can be done. IoT-based sensors should be installed on all critical assets, and these IoT-based sensors should be providing data to a centralized data lake where duplicity should be eliminated. If the data is already available into the ERP system, there is no need for duplicating this data into the APM system. There should be a API-based calls that is constantly getting executed into the ERP system, and the output is coming from the ERP system into the asset performance management system, and that output is utilized for inventory management, workforce management, workflow management, and also maintenance and repair activities. All of this APM system or APM, I would say, ecosystem must be fueled by advanced machine learning based analytics for asset health index calculation, risk index calculations, and also asset specific analytics for fault identification and corrective actions. And definitely, if I talk about the real optimization on or dynamic rating of electrical assets, a scenario based analysis or what if analysis should be provided so that the day-to-day operations can be optimized. Typically, if we talk about the APM processes, so it starts with identifying the critical assets, collecting the data related to the condition monitoring or related to the health assessment of these electrical assets, then analyzing that data to come up with the key insights. And those key insights are, what should I do with my electrical asset? Should I operate the electrical asset? If I want to operate the electrical asset, can I overload this electrical asset? If I cannot operate the electrical asset, should I go for replacement, or should I go for a major repair, or should I go for a small repair? So such kind of decision should come from the APM software or APM system. Then These insightful decision or insightful analytics should also provide the recommendation for corrective or preventive maintenance. And those corrective and preventive planning should be based on these insightful information we have got from these analytics. And then all of this process needs to be implemented and followed into asset management and maintenance practices on a day-to-day basis. So the change management is also a critical process in a successful implementation of APM strategy. So now if I talk about the analytics part, where we will be focusing more on today, what are the different kind of analytics APM system should have for different kind of objectives. So if I, like we discussed about collecting the right kind of data, and collecting the right kind of data is very, very important for a successful implementation of APM processes. And that data can be data coming from offline testing, periodic testing, or inspection records. The data should also come from online monitoring system for electrical assets that are getting into the worse health condition. And the data should also include the historical failure data. So historical failure data is very, very important to predict the failure of a particular electrical asset. So how it works is, from the condition monitoring data, from the environmental data, the analytics are calculating the current health of the electrical asset. Then from the historical data, the analytics are implemented for predicting the failure of the electrical asset based on the historical data. And then this probability of failure or failure prediction combined with asset health, current asset health, gives the risk index of the electrical asset, how risky the electrical asset is from the operational perspective. And if I add the criticality of the electrical asset into the risk index, it becomes more useful for the utilities, because now the criticality is also included into the risk index. So that's how it works from the data perspective. And the similar kind of data, like offline testing data, visual inspection data, condition monitoring data, also helps in predicting the fault into the electrical asset and then giving the recommendation to rectify this fault. So if I talk about the type of analytics, there are two types of analytics. Generally, you will see one is fault diagnosis or fault identification analytics, and the second one is planning related analytics. And we'll talk about these two types of analytics in the future slides. And then when we talk about in both kind of analytics, whether predicting the fault or doing the planning is based on health index or risk index calculations. All of these calculations should eventually go from human expertise based analytics to machine learning based analytics. And that is where the concept of digital twin comes to. So we should have asset simulators, we should have digital twin of each electrical assets, so that scenario planning and dynamic rating becomes more easy or easier to our maintenance and operational guys. So if I talk about the typical or today's approach of health assessment analytics or asset health index calculations, you will see mainly two kinds of approach. One is failure mode effect analysis, FMEA approach. Another is root cause analysis or RCA approach. Both approaches are roughly the same. So I'm mainly focused on, today's presentation, I'm mainly focusing on FMEA based analysis, failure mode effect analysis, which is fundamental to pretty much every electronic or electrical design. So how it works is, if I talk about the product development life cycle, so during the product development life cycle, one of the first thing any design engineer does is what are the typical failure mode effect or failure modes of the design, and from those design failure mode, uh, typically similar kind of failures are being seen in the real time situations or in the real time failures of the electrical assets. So what a typical analytics or analysis algorithm should do is define the events that causes an asset to fail. Like take an example, transformers. What are the different failure mode of a transformer? And that will come if I divide the transformer into major components like bushings, windings, main tank, oil, and then identify what are the failures of individual components of the transformer. And then what are the parameters that will help me to predict these failures? And once I have predicted the failures, then it becomes easier for me to come with the current health of the electrical asset, and also it becomes easier for me to find it out the fault and the recommended action to rectify that fault. So that's why FMEA based approach is generally preferred approach for both kind of analytics, whether it is asset health index analytics, risk index analytics, residual life assessment, or the same analytics can also be used for asset simulators or what if analysis tools, or asset management or maintenance management practices and inventory planning. So let me give you an example of a transformer. So on a transformers, typically a transformer, the main component of the transformers are bushings, cooling system, winding and magnetic circuit, main tank and oil, and OLTC. And what you are seeing on the screen as a sub bullet point on each component is the typical failure mode of those components. So if I talk about winding and magnetic circuit, so typical failure mode of winding and magnetic circuits are overheating related issues, excess moisture related issues, bubbling related issues, partial discharge related issues. That could be because of loose connections with the bushing or some loss of core ground current, unintentional core ground. So these are the typical failure modes of the winding and magnetic circuit. And if I just stick with the winding and magnetic circuit, so what are the different parameters that can be used for predicting these failure modes? So first of all, I need to have the parameters or test results to predict those failure modes. So what you are seeing on this slide is on the left hand side with the orange, you are seeing all the failure modes, and on the right hand side, you guys are seeing all the parameters that can be used for predicting this failure mode. And where today's our customers are getting into another problem is installing every sensor to predict that failure mode. So if I just talk about winding and core overheating issue, so this can be detected by fiber optic temperature sensors, installing a fiber optic temperature sensors on winding and core. It can also be detected by multi-gas DGA or oil sampling, ambient temperature, oil temperature, excitation current, gas accumulation relay. So all these sensors are used for predicting this failure mode, which is winding and core overheating. But if I talk about minimal sensor, so only fiber optic temperature sensor, if it is installed on the windings, that is more than sufficient to predict this failure mode. So this is another thing our customer needs to understand is install best and optimal sensor on the transformer that gives the failure prediction with a sufficient accuracy. And once you get the sufficient accuracy, first of all, it reduces the data to analyze. So it reduces the confusion to the operation engineer or maintenance engineer. And the second thing is it reduces the cost of implementing the monitoring system. So that's why identifying the critical parameters to predict that failure mode is very, very important in a APM system implementation or using the analytics from any analysis tool. Once you have the right set of data, your prediction will be right. Okay. And then this is just an example how a typical user interface should look like. So this is an example from one of our APM software called RMEYE, where the health index, criticality index, and risk index are shown on a transformer dashboards. And again, these health index is driven by health index or health score of individual component. So on the top right hand side, what you are seeing on this image is different component of the transformer and the health score of these components. And the health score of these component is being calculated by different parameters. And those parameters, what I have listed down for the winding taken example, are the parameters we have used. And again, this is just the one set of parameter. There are other sets of parameters that can also be used for winding health score calculations, like electrical testing, like turn ratio testing, your winding resistance testing. So all of this electrical testing data can be utilized for winding health score calculation. Similarly, if I talk about the main tank health score calculation, main tank health score calculation is generally being driven by the visual inspection as well as the offline testing of the electrical asset. Like visual inspection, very simple. Leakage. If the leakage is being observed from the main tank, the health score of the main tank goes higher. So higher means it's going towards the worst direction. So typically in this particular software, 0 means very good and 5 means very bad. So that's why if I'm saying higher, so higher means it is going towards the unhealthy conditions or towards the poor conditions. So every piece of information related to condition monitoring is very crucial. I'll give you an example of the maintenance or repair. So if the oil regeneration has been done on the transformer, and if we just rely on the oil health index based on the different gases composition and different oil quality related data, then after regeneration, the oil health index becomes really good. But we need to factor into the oil regeneration that has happened into the transformer. So how to factor this oil regeneration into the new health index that new oil health index that is being represented after regeneration? Definitely, the health index will improve after the regeneration, but not as much as a new transformer with the similar kind of gas composition. So this kind of data is very, very important to consider while we are coming up with the health index calculation or risk index calculation of a transformer. Then, as I mentioned you guys, that machine learning, so slowly this has to move from expert dependent or asset expert dependent to the machine dependent calculations and machine dependent recommendation. But this is in the electrical industry, what I have seen is it is still a lot of data will be needed if we want to improve the accuracy of the machine learning analytics, especially for asset health index calculation and risk index calculations. So certainly, if I talk about the electrical asset, we are at the almost initial stage of our digitalization, where all this data is being collected, especially condition monitoring data is being collected when the fault condition is happening. So if we have lot of such kind of data where we have collected the condition of different parameters and their values just before the failure of the electrical asset, then that data becomes more useful for implementing the machine learning analytics or implementing the analytics for a automated future prediction. Some examples how the asset health index or risk index calculations can be used for planning purpose. So like what you see, that if I have the health index and risk index for all of my assets, then I can use these values to plan for 1 year, 1 month, or 5 year maintenance and replacement planning. Another example where lifetime consumed index and failure index can be utilized for identifying the fleet of assets that needs highest attention versus identifying the fleet of asset that can be operated at the overload conditions. Another example, criticality index versus health index. So higher the critical asset and higher the health index, we need to consider that electrical asset for replacement or repair strategies. So these are some of the example of the dashboards I'm presenting it to you, but underlying data or information underlying these graphs is the collecting the accurate data and using this data for asset health index and risk index calculations. Now coming to the asset specific analytics, I'm giving mostly here transformer related examples to all of you, because most of you, I'm assuming that you are familiar with the transformer related analytics, because this is widely used analytics in the industry. But similar kind of analytics are available for other electrical assets as well, and we can have a separate webinar for this for other electrical assets. So this next, previously we talked about asset health index, risk index, criticality index related analytics. Those are coming from predicting the failure of individual component by capturing the parameters from different data sources like offline testing, inspection records, online monitoring data. Now I'm focusing on how the same data can be utilized for predicting the failures and also recommending the corrective actions for those failures. Okay, so take an example, oil analysis. So if I get the oil analysis data, whether it is coming from oil sampling or it is coming from the online dissolved gas analyzer. So if I use different kind of analytical tools like dual triangles, dual pentagon, Nuremberg ratio, IEEE, IC ratio, so these tools are helping me to identify the possibility of a fault developing into the transformers and then a recommended action for this. So such kind of analytics are available today. Either they are available on the, you can say, on the web, like IEEE, IC, CGRE. They have published different kind of analytical models that are there for predicting the different kind of conditions on the electrical asset, or they have been published by different research scholars. So the idea is identifying the fault before the failure occurs and then predict and then recommending the corrective action for that particular fault. So this is called asset specific analytics. And here the alarm purpose, the notification, SMS notification, email notification becomes very, very important, because as soon as the APM system sees a developing fault, the alarm should be generated, and that alarm should be sent to the respective maintenance and operation person for an action. And that action is not reactive action. We need to consider this is very critical to understand. This is not a control system. This is not a SCADA system. The alarm is not reactive. Alarm is preventive. So you still have sufficient time before actually the asset fails. So that alarms needs to be taken seriously, but at the same time, the action needs to be planned. The action, the need for the action is the planning. We need to plan ahead for that particular failure. So that is where we need to again have a change in the philosophy of alarm management between the alarm of the SCADA system versus alarm of the monitoring system or APM system. Okay. And then how can we utilize this whole APM system for optimizing the inventory. So today, if I talk about, like inventory of transformer, I'm giving an example of transformer again, inventory of bushings, fans, motors, radiators. So if I talk about these inventory, like inventory of your sensors, OTI, WTI, PRDs, how can we optimize this inventory and increase the bottom line of the company? So again, this should be fueled by uh, APM software. So APM software must have the inventory planner, and this inventory planner, it takes the data from the ERP system. And again, we are not here talking about the data duplicity. We are talking about getting this data on a real-time basis whenever the inventory management or inventory forecast is needed. An API calls the ERP system, gets the relevant information related to the forecast of the inventory, performs the inventory forecasting, and gives the inventory forecast to the ERP system. So let the ERP system do the inventory management, and the APM software, what we are calling about RMEYE, it performs the forecasting based on the asset condition and the current inventory related to that particular asset. Okay, so that's how the process between ERP, that's how the ERP and APM software should be integrated with each other. Now, if I talk about the IoT sensor, how the IoT sensor can enable or can improve this APM software, definitely there's no doubt that if we have the sensors on the electrical asset, and if these sensors are sending the data on a real-time basis, lot of things can be automated. We don't need to go for lot of periodic testing. We don't need to go for a lot of visual inspections, and the asset health index, risk index, fault diagnostic analytics, these are running almost on the real time and giving us the real time information about the electrical assets, and the performance of the electrical assets can be measured more accurately and in a better way. Okay. If I talk about the APM modules, so how does a good APM system should look like? So the APM system must have different kind of modules. So if I talk about the integration, so it should have a integration flexibility to integrate with different kind of data, like historical offline testing data, ERP system, maintenance management system, workforce management system, SCADA system, and data historian for getting the operational data, historical operational data. Then monitoring device integration. So whatever monitoring devices are already installed on the electrical asset, and whichever monitoring devices are coming in future, all of these should have a easy integration flexibility with the APM system. And then it should have a good security system integration for maintaining the data security and cyber security. For operational management, it should have different kind of features so that it helps the maintenance engineers and the operational engineers to manage their day-to-day operations and track their KPIs. So like alarm management, SMS email notification, your asset specific analytics, history trending, grid view, all these features, dashboards, my dashboards, all these features are very, very relevant for day-to-day operation of these guys. Then the entire APM system should be based on advanced analytics for asset health index, risk index, criticality index, residual life assessment for lifetime extension, asset fault diagnostic models we discussed about. It should have a library of asset models so that if any new asset comes, it can be instantiated in a faster way. And then a flexibility to move to the digital twin models. From the reporting and dashboard perspective, it must support regulatory reportings, management reports, performance reports, cybersecurity reports. All of these reports are necessary for some or other purposes like environmental and safety related issues, then cybersecurity audits, then your company performance related management. So those kind of dashboards and reporting should be available with a decision support system for inventory planning, maintenance planning, and asset management planning. What are the typical attributes of the APM system? It should have platform scalability. So it should be scalable from one substation to a entire company level, or even if there are companies which has multinational subsidiaries, it should also support such kind of implementation. We always recommend to go with OEM agnostic approach, just to eliminate the possibility of any conflict of interest. Then easy to retrofit for an existing asset. The APM system should be easy to retrofit, easy to install, and easy to integrate. Cybersecurity, no question about the cybersecurity explanation. Integration flexibility with minimum cost, especially with the legacy databases, especially with the legacy monitoring system. Then advanced modeling strength with customization flexibility, machine learning, digital twin, support for monitoring as a service or analytics as a service. This is again very important. Many of our customers I have seen, they have already invested into a different kind of APM software or a extension of their ERP system as a APM software. So in those scenario, if there are analytics that can be directly integrated with the existing APM system or existing ERP system, that will be the better approach than providing a completely new APM software. And certainly ISO 55000 implementation and expert analysis services for asset health assessments are critical. There are few challenges on APM implementation, what we have seen by talking to different customers. So one of the biggest thing, or everywhere we heard, is we have been hearing is IT versus OT. So certainly the IT team and OT teams are different, and somehow it is APM system vendor's responsibility to make this integration happen and to make this integration almost a seamless integration. Then limited technology infrastructure. Many of our customers, they don't have infrastructure for IoT sensors, especially for retrofit applications. And then the industry-wide, there is a lack of data. Data means relevant data. So relevant data means the data of condition of the electrical asset just before the failure of the electrical asset. So such kind of test data is not available, so that the analytical accuracy or analytics accuracy can be tested. Then managing organizational cultural changes, like I told you previously also, this is a system-wide implementation. It should be implemented like a typical business process implementation, where we understand the current landscape of the customer and their current system landscape, and provide a future landscape and future process changes because of the APM system. And then complexity of data analysis. So certainly, there's a lot of data available at different, data sources, like I mentioned at the beginning of my presentation. How to best utilize this data without creating another, database, or without creating a duplicate database. So that's where the challenges are there. Certainly, it requires a system integration approach, or it requires a business process analysis approach, not just providing the APM system. And this business process review approach will help utilities and the industrial customers to move to the future state of the APM implementation in a faster and easier way. So that's all about the presentation, guys.
I have a question, Amit. Is it possible to share successful cases?
Yeah, that's a good point. So one of the successful case, guys, I can only talk right now because I need to get approval from the customer. So one of the successful case study we have done is one of the largest refinery complex in the world, where we have installed our APM software in 200 electrical assets in that refinery. And we are monitoring around 25 transformers, 30 plus power cables at 33 kV and 220 kV, then electric motors, generators, medium voltage switchgear, high voltage switchgear. That includes gas insulated switchgear, air insulated switchgear. So we are getting both kind of data, like offline testing data, condition monitoring data, visual inspection data, and then utilizing that data in creating the different kind of analytics I have presented into the slides, like fault diagnostic analytics and health index and risk index related analytics. And then we have given good results for their assets. Some of their assets, like I can tell you, the two transformers, we have identified the faults in the two transformer, or at least the health of those two transformer has gone down. And when they did the independent analysis with third party, just to check, verify, they did the independent analysis with third party testing companies, and they found the similar kind of results. So it certainly proves that the health index related calculations and fault diagnosis related calculations what we have given are accurate enough, and it is helping them to improve their current practices. So for example, previously they were going for visual inspection, and with the visual inspections they were filling up the different forms, and those forms and visual inspection reports were getting into some Honeywell system, and then the asset experts were analyzing those reports, and it was taking like 1 month to 2 months of time. While with our system or APM system implementation, all of that has been automated, where the service engineers, they have APM software application into their tab. They're going for the visual inspection, filling the data or filling the visual inspection report online on the tab using this APM application. And then instantaneously the asset health index or asset health score is getting updated. And if any unusual activity is happening, like leakage is happening, the asset health score will drastically go up, and the alarm and notification goes to the experts. Experts are looking into the systems, they are providing the recommendations. Those recommendations are then flowing to all the relevant people into the company, and all of this is happening instantaneously, guys. It's not that someone will have to wait for someone to upload the data into the Honeywell system, and then someone to access the system, and then create the report. So everything is automated. So similarly, the same automation has happened into the offline testing data. Same automation has happened into getting the fault records from the relay system, and then analyzing these fault records, or doing the after fault analysis of these fault records. So APM system can also be utilized for integrating those fault records, and then giving the flexibility to view the fault records and audit the fault records. So that's one of the many installation we have done, where we have shown the value of the APM system to the customer, and they have agreed on the value, and now they are expanding this software or this system to their 10,000 electrical assets. That's one success story. Okay, thanks everyone. Thanks for joining the webinar. Have a good day, and some of the guys have a good evening. Bye-bye.